Hey guys, it's Horner, and I just want to take you through. We're going to talk a lot about today. Um, I'm going to close that window for just a second because something came up here. And let's try this again, and we'll get into the right thing. Here we go. All right. So now you're going to be able to see. This is all about position and time graphs. And the big thing here I think you have to remember is graphs are a lot like pictures. There actually are worth a million words. So anytime you do a graph, you are telling the College Board readers, the people who actually sit down and look at all your work, you're telling them that you really understand your physics just based on what you do on your graphs. So I think this is probably one of the most important things that you can do. And it's one of the easiest things you can do to get points. So this is going to be, this should be really good for you all. I just want to make sure that you can hear me. Right now, there are 2 people live. And so either one of you, if you don't mind, now I've got 3, which is awesome. We've got 65 or so registered. So we've got more people coming on here. Just down in the bottom corner. So down in the bottom corner, it says, say something nice. There's a chat there. Just say hello. Say yo, say something, just so that I know that you can hear me. Awesome. Good job. All right, cool. So let's take a look at these and see what we can figure out. One of the things I want to remind you is that you can always go to Twitter, or you can go to Instagram, or you can go to YouTube, and you can kind of look at some of the things that we've done. But if you do and you like it, just give a shout out to @Fiveable. That is who sponsors these events. We absolutely love doing them as teachers because we just want students to be successful. So no matter where you live or where you're at, that's why we're here. We're trying to get you to be successful. We want to make sure that you're ready to take this test. And if you can help us spread the word, that will help more and more students. So you're actually doing your everybody around you a huge favor for doing that. All right, there are some other streams this week. So on the 18th, Peter Apps is another physics teacher. He's going to talk about velocity versus time graphs. I'm doing position versus time graphs, so we're going to look at a lot at those. He will go over velocity versus time graphs and show you how they relate to both the graphs we're doing tonight, as well as a lot of the graphs that are acceleration versus time too. On the 19th, Casey Lee is a phenomenal student who knows an absolute ton about AP Physics 1. And Casey will be going through problem-solving practice and Q&A. His sessions are super popular, and he does an awesome job going through things, really trying to help you all do some really cool things in terms of problem solving and answering a lot of your questions. So you want to make sure that if you have time, you can get on and do that. So what are we going to do tonight? What we're going to do in the 50 or so minutes that we have, first thing is we're going to talk about some of the terms that they have on the AP Physics exam. Since these are position versus time graphs, we really want to make sure that you understand the difference between when you need to plot an actual graph and put numbers on it and label the axes, and when you just have to kind of sketch, because sketching is a lot easier than plotting sometimes, but not always. And then we're going to talk about what you absolutely must have on a graph to get all your points. It's a good thing to always review, something to go back and take a look at, especially if your teacher is not going through this with you much. I try to show this to my students as much as humanly possible. By the way, my name is Christian Horner. I am a teacher at Westfield High School in Westfield, Indiana. All right, so slope determination, we'll talk about how to figure out what slope is. We are going to look at curves on graphs, and we'll find out that they do have names. We're going to find out what happens if you accidentally flip your axes. So instead of putting the correct things on the Y and the X, what happens and how you can go through and actually use that graph to be able to answer a question, which is kind of impressive. On your end, that'd be awesome. So then we're going to actually start looking at the position time graph. So we'll look at horizontal ones, we'll look at ones that have positive slope, negative slope, and then we're going to look at all the curvy graphs. At that point, we'll take some questions and we're going to kind of integrate some practice as we go through. So we'll make sure that you're set. All right. Graphing on the AP Physics exam. So this is a typical thing that you will see. You will see that they will ask you some guided question. And this part would be maybe part A. So in part A, they would say, plot the following data on the provided chart. Make sure that you include all of the axes, blah, 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 and they're going to give you a lot of verbiage there. All you need to know is that you need to make the best graph that you have ever made. Make it very clear as to what you're doing. So the first thing you're going to look at is this is our independent axis. Okay, so this is our independent variable. For some reason, they looked at times 15, 16, 17, 18, 19, and 20, and they plotted the positions for those. So they plotted position 2.2, 3, 3.9, 5.2, 6.1, and 6.9. So obviously, this is something that is moving. Okay, so this is our dependent variable. Typically, when you graph things in AP Physics, especially if you're using Microsoft Sheets, Microsoft Excel or Google Sheets, even when you're using Desmos calculator, that you'll want to have the X variable first. So this is our X variable. This goes on the X axis, and then our dependent variable would go on the Y axis. First thing that I would always do before you even start the graph is go ahead and put on your axes labels and units, because typically you're going to get 1 point for having those. So what I'm going to do is go ahead and write the word position. And that position, oops, you know what? I've already messed it up. So remember, it's okay to make a mistake on the AP Physics exam. If you cross off what you do wrong, then you can actually write in the correct answer, and they will ignore whatever you cross off. So this axis, remember, is the first column, and that is the x-axis. And so that is time, and we want to put our unit, which is a second. Units, I just abbreviate with the 1 letter, or sometimes they're 2 letters, whatever those abbreviations tend to be. The other thing we need to put on here is our y-axis label, which is position. So I'm going to put position. And I want the unit for that, and that is in meters. 90% of the time, they're going to want the units in standard SI units. So remember, the standard SI units are for mass, it would be a kilogram. For length, it is a meter, and for time, it is a second. So those are your basic units. So Kigmas, sometimes you'll hear that, or King Miss, kind of up to you, however you want to do that. But let's go back, and now we've got to go through and make sure that we scale this correctly. So the first point, we actually get 1 point on this graph for having our labels and units. And for this graph, you really could put time here and position here, but then when you solve for speed, which we're going to do later, or velocity, you're going to have to modify your answer so that you actually have the right thing. Okay, so let's go back to this. Notice I don't have a title. Most of the time they don't ask for a title, but if you do need a title, that title should always be your Y label, which is position. So this is position versus, and then your X label, and your X label here is time. Okay, cool. Now, what I want to do is I'm going to make the graph. And my question for you, so that you can do a little bit of thinking here, is, do I have to put 0 down here at the bottom? So just tell me yes or no, and I'll kind of watch and see what you say. So either yes or no. Don't be afraid to go ahead and type an answer. If you're wrong, it's cool. We won't say anything about it at all. But do I have to put 0 down on the bottom? So I'll give you a second here. So either yes or no. And I see one person has voted. Anybody else want to vote? I'm going to give you 5, 4, 3, 2, 1, 0. Okay, so here's the deal. If you put 0 here, but your first number is 15, then you're going to have to figure out a way to scale this so that you get to 20 over on this side. The only way to do that would be to put a 0 here, and then a 10 here, and then a 20 here, which means your graph is really only going to fit within these 2 boxes. The rule that we have when we grade these is you need to fill up at least 1/2 of the boxes. There's 30 boxes here. How do I know? There's 6 across here, and there are 5 going up. So that's 30 boxes. I need to fill up 15. So let's go through and figure out if there's a better way to do this. If you do put 0 here, and then you have to put 10 here and 20, we're not going to fill up enough. So you are more than allowed to go ahead and start at the number 15. So I'm actually going to put 15 here. I'm going to double check 15, 16, 17, 18, 19, 20. Cool. So 15, here I'm going to put 16, 17, 18, 19, 20. And it is okay if you go past that. I could have also started at 14 and then put 15 here, 16, 17, 18, 19, and 20. Doesn't matter as long as your scaling is correct. So you couldn't go 15, 16, 17, 20, 22, 50, and 100. That wouldn't even be logarithmic. So you really want to be careful what you put there. Then when I do position, I see that I'm going from 2.2 all the way up to about 6.9. So I'm going to round those. That'd be about 2 to 7. So if I start here, this would be 2, 3, 4, 5, 6, and that's perfect. It works out. Most of the time when they do this, they will give you numbers that work out pretty well. So that's 2, 3, 4.0. This would be 5.0. This would be 6.0. And then finally 7.0. If that's correct, what do each of these little tick marks, what are the values for the space in between the two? So if this is 3, what will be my next mark up? So I'm going to actually ask you that question and let you go ahead and type, because that'll kind of keep you involved. So if my dark mark here is 3, and I've got 1, 2, 3, 4 until I get up to number 4, I'd have 5 lines here in between the two. What would I put? Yes, correct. Good job, Catherine. So that would be 0.2. Actually, perfect. Great, Graham. Awesome. So these are 0.2, 0.2, 0.2, 0.2. So this would be 3.2, 0.4, 0.6, 0.8, and 4. Now that you kind of know that, we can do the same thing on the bottom. So they do this on purpose. They want to make sure that you're able to plot things correctly. There's really no physics here, as you notice. It's just plotting a graph. So how cool is that? You get 1 point for just putting the labels in the units. Now we're going to put 1 point for plotting. So by plotting, what we mean is you have to have your dots in the right spaces. So let's start at 15. Notice I want to be at 2.2. So I'm going to put a dot right there. The next one is 3.0 and 16. So 3.0 and 16. So I'm going to put a dot there. Then I have 3.9 and 17. So 17 go up to 3.9. Remember, that one's going to be in the space. For 18, I'm going to go up to 5.2. And then I'm going to just keep going. 19 is going to be 6.1. So it's about right there. And then finally 20. 20 is going to be 6.9. You don't want to add any dots after that. We want to just keep the dots that we have here. Here's my next question. If I need to draw a best fit line, which I do right here, my question is, do I get to use a ruler to do that, or do I just have to do that by freehand? So are you allowed to use a ruler on the AP Physics 1 exam in order to draw straight lines? Yes or no? What do you think? Can you use a ruler? Is that a approved device on the AP Physics 1 exam? So I've got one person that says no. Anybody else want to vote? It's either a yes, you get a ruler, or no, you do not get a ruler. And I'm going to give you 5 seconds. 4, 3, 2, 1. I have one no and one yes. I would love to split the difference, but we can't. You actually do. If you read the AP Physics 1 testing manual, you are allowed to use the following things. A number 2 pencil, and you want to make sure that it's an actual pencil and not a mechanical pencil, because some of the mechanical pencils, the way that they shade in doesn't always get caught by the scanner. A true number 2 pencil is the way to go. Make sure you have several of them sharpened so that you can just keep going. An eraser. You can also have a scientific calculator or a graphing calculator, either one, as long as you can't type on it in terms of it has a QWERTY keyboard that you can have. And then the other thing that you can have is a ruler. So they allow you to have a ruler. Now, if you write anything on the ruler, like you give yourself some hints or things, that is violation of testing policy. But you can have a ruler or a straight edge that is approved. So you want to make sure you do that. Here's why. We want to see really straight lines whenever you draw this. In fact, they've got to be straight enough that when you draw from one end to the other, you want to have the same number of points on the top as you do on the bottom of the line. So if I drew and kind of did a sloppy one and I did kind of like this, it would not get any points. And it's because you'll see all of the dots are on the bottom of the line. So it's not really a best fit line. If I do this and I do it correctly with a straight edge, you're going to notice that I'm going to probably have 2 points above the line and 2 points below the line, along with a couple of points that are right on the line. So that's super important. So you get 1 point for labels and units, 1 point for plotting. And part of that plotting is making sure that you fill up at least 15 boxes. So you got to make sure you fill up those 15 boxes. And then typically you get 1 more point. That last point might be for the best fit line. So that's BFL. That's different than your BFF, because it is your best fit line, not your best friend forever. But this line could be your best friend forever because it will get you a point. But that best fit line needs to be very, very straight. So you need to make sure that you use a straight edge. All right, so that is the graphing part. And those are the rules that you really need to follow. How do I know that it's filled up at least 15 boxes? If you start at your very first point, okay, and then you move horizontally over to where your last point is. I'm going to go up, and here's my last point. If that point is on the line, we typically say anything to the left is valid and anything to the right is not. So I'm not going to count the boxes here, but I am going to count all of the boxes left to right and then bottom up to the box that this is just to the right of. So you'll notice that I've got 5 boxes by 1, 2, 3, 4, 5 boxes. So I filled up 25 boxes. And so that's perfectly fine. You only need to really do 15. We prefer that you do more than that because it's a lot easier to see if there's a curve or not. And so that'll help you. All right, cool. Let's go on to the next part, okay? This is actually going through and figuring out what the slope of the line is. A lot of students make the mistake that when they draw their best fit line, they go, oh, look, I've got a couple of points that are really close to, if not right on the line. You actually should never use those. You should always come up with your own 2 points. The reason the College Board does that is because they don't want you just picking 2 points and coming up with an answer, because most of the time they've made it where none of the points that they give you, or maybe just one of the points, probably fits that best fit line. They want to make sure that you're doing this the correct method, using the correct method to do it. So whenever you do the best fit line and you're finding the slope, the first thing you want to do is circle any points that you're going to use. So it looks like right at 6 and 19. So I'm going to just double check 19. Ooh, 6.1. Good. So I can actually use this point right here. So I'm going to put an X there and circle it because I'm going to use that point. And I'm going to also label it. So I'm going to label it as 19, 6, so that the person who's grading the test actually sees that I am not using one of the points on the table, okay? And by one of the points on the table, I can use one of the numbers. I just can't have it pair up to the exact number that's in the table. So I use 19.6, and that's because there's some variability because of my best fit line is more of an average. The other place that it looks like it goes through really well is right here. And this is at 16 and 3.2. So if I go here, you'll notice it's 16 and 3. So this is a perfect way to do it. This is 16 and then 3.2. All right, so let's find our slope. In order to find the slope, we're going to say m, which is equal to slope, is the change in the position, or you could put change in y, but they usually want you to have an equation. So change in position over the change in time. So you want to show your work as you do this, because typically we give work for this. We're not real worried about the actual physical number sometimes. We're more worried about, are you using the right process? And we're double checking to make sure that you have not used points that are on the table. So let's prove that we're not using points on the table. We're going to take 6, which is our final position, minus our original position on our best fit line. So this is going to be 6 minus 3.2, and we're going to divide that now by 19 minus 16. So at this point, what I'm going to have you do is go ahead and pull out your cell phone, if you're not already on it, and or a calculator, and I'm going to have you figure out what is the slope of this line. The other thing I'm going to have you do is give me a number, and also, if you don't mind, give me the correct units for the slope of this line. So I'm going to give you about 30 seconds or so to try to do that. On your mark, get set, go. I will give you a countdown here. So we'll start the 30 seconds right now. Got 25 seconds. You have about 20 seconds. Not to rush you or anything. You have 15 seconds. Ah, Catherine has one. Good. Graham has one. And we've got about 5 seconds. And time is up. So when we go through and do this, we're going to take 6 minus 3.2. And then we're going to divide that by 19 minus 16. So 6 minus 3.2, that gives us 2.8. And we're going to divide that by 3. And so we end up with 0.93. And then, Catherine, you are 100% correct, 0.93 meters per second. So that's very good. It's really easy sometimes to make a mistake in the math. And that's why they typically, for this, will give you 1 point for actually showing work, and then 1 point for not using any of these. So that would be 2 points. They're not too concerned about the answer. They might give it a point, they might not. Kind of depends on what they've talked about at the reading. So excellent job. You guys are doing a great job. Let's move on and take a look at some curves, okay? So one of the things that I know I have my students go through and do is take a look at graphs. And so we've got 4 graphs that we're going to look at, okay? So they're all y versus x, but we could go ahead and say that these are all position in meters and time in second graphs, okay? So we want to give the graph shape. We're going to talk about what the relationship is, and then we're going to give the equation for that graph. And we're going to do it using the position in time. So position in meters and time in seconds. So this first one, the shape of this is a line. So this first shape is a line. The relationship that we have for this one is linear. And so now my question for you is this: what is the equation? What is the equation for a linear curve? What is the equation? And we just want the math equation. Then I'm going to show you one more thing that should be kind of helpful here. So go ahead and type in the chat box, what is the equation for a linear relationship? And you can do it in terms of y, m, and x. Let's see what you get. Yes, that's absolutely correct. So y is equal to mx. For this one, we don't have a b value, but typically you would have a b value for this. So this is y is equal to mx plus b. And then for our particular graph, it would be the position x is equal to, and then the slope of the line. Well, because it's meters per second, that would be our velocity, and that would be in meters per second. And then we have to multiply that times the time. So x is equal to v in meters per second, and that's our slope, times time. Very good. All right, let's take a look at the next one. So this one, what is the shape of this curve? So the question I have for you then is, what would we call this shape in math? So one of the things that I do for my students is I draw a roller coaster, and then you've got a person inside the roller coaster, and they are screaming at the top of their lungs on the way down. And on the way down, if you're screaming and you're really just flipping out, we would say that you're hyper. And so I like to say this one is a hyper. And then if you think about a bowl, like a cereal bowl, this would be the front half of that bowl. So this is called a hyperbola. And usually when you go upside down, when you're on a roller coaster, we would also say that that is inverted. So if you were inverted, the relationship here would be inverse. And then finally, the equation we're going to use for this is y is equal to our slope times 1 over x. Now, why did I do 1 over x? Well, we said that the relationship between y and x is 1 over x is proportional to y. And that is our relationship and the equation that you would use. All right, cool. Let's go ahead and take a look at the next two shapes. This shape is called a parabola. And the best way to remember it, parabola, the best way to remember it is, remember we talked about the bowl in the last one? We said that the front half is the hyper part of the bowl. This is the other side. And anytime you have two sides to something, for example, you might have a set of jeans. We don't call them a set of jeans or a set of shoes. We call it a pair. And so this is the parabola, and this is the para side because it is a pair. I know it's really bad, sorry. Our equation for this is y is equal to m times x squared. X squared, because we know that that is how these are related. This goes up a lot every time this one goes up just a little bit. So that's kind of what we'll see here is y is equal to mx squared. And so we call this relationship quadratic. Y is equal to mx squared. And that is our equation. So let's do the last one. This last one is kind of upside down. And our relationship for it is actually called square root. And there's not a math term for this. So math has kind of failed us here. So instead, what I tell my students is to remember that if you watch Guardians of the Galaxy, you'll see that there's a tree-like figure. He kind of looks like this, and he's got a couple eyes here, and he says, "I am Groot." And so this one I affectionately call Groot. And the equation that you can use here is y is equal to the square root of x. But I don't like this one very well because sometimes it's really hard to find the square root of the whatever the x values are. So it's much easier to do y squared is equal to x. These are interchangeable. They mean the same thing. They give you the same result. And so I actually wouldn't use this one. Instead, I would use the one on the bottom. All right, so those are curves on position versus time graphs. Let's go ahead and let's talk about if you flip the axes. So for some reason, let's say that you're in a rush and you forget that you probably should have put time on the X and you put position on the Y, and that's where you're supposed to put it, but instead you decided that you would put it on the X. So you're going to get a very familiar graph. You're still going to kind of get that graph that we got before, but remember our slope from earlier. So we're going to go back to that slope again, was 0.393 meters per second. If you end up making the mistake of putting the things on the wrong axes, it's actually fine. What you'll end up getting then is your slope, when you find your slope for this one, is going to actually be 1.08. And you'll see that that is a second over a meter. So the minute that you write the physics equation, you go, well, time is equal to 1.08 seconds per meters times position. So there's our physics equation. You go, oh, that's not right, because this is 1 over velocity. If they ask you for the velocity, all you have to do is say, well, if 1.08 is equal to 1 over velocity, I need to solve for velocity. Well, how do I do that? I divide both sides by 1.08, multiply both sides by v. And if I do that, v is equal to 1 over that 1.08. And so my velocity then would be 0.93 meters per second. So it's okay if you flip it accidentally on the test, as long as when you find the slope and you're trying to explain what velocity is, you do this. And that makes it a lot easier. All right, cool. So we're about 30 minutes into what we're doing. And so now we're going to move on and we're going to take a look at some actual position versus time graphs. Okay. And there are several different ones that we can look at. The first one that we're going to look at is a position time graph. So these times are actually 0, and then this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So you say that we're going all the way across over to 10, we're going up to 10, and then our very bottom line here is negative 10. I just didn't get it in there. So what I'd like to do is I'm going to draw a line, and then this is the interactive part again. I'm going to have you pick and tell me which of any of these letters the graph matches. So if I start by saying, okay, well, I know that I've got a person and I've kind of found out that their position at 1 second is 6, at 3 seconds is 6, at 5 seconds is 6, and at 7 seconds is 6. And I go ahead and draw my best fit line. Oops, sorry, that's not the best fit line. Always make sure you use a ruler, but I don't have one for my little drawing tablet here. So I'm going to get that. I've really messed that up badly. My question is, which one of these would that meet? Does this one have no velocity, constant positive, constant negative, increasing velocity in the positive, increasing velocity in the negative, decreasing velocity in the positive, or decreasing in the negative? And you don't have to type out the whole thing if you don't want to. You can just put A, B, C, D, E, F, or G. I have a vote right now for no velocity. Anybody else want to back that vote up? Very good. Excellent. So this one doesn't have any velocity. Why does it not have any velocity? So one of the things that they're going to ask you to do on the AP Physics exam is they're going to ask you to go through and explain why something happens. So the easiest way to do that is to use the ABCD format. So we're going to say A, B, C, D. So we've answered the question. We said that there is no velocity. Now we need to use basic physics. So the basic physics for this is, if I have a horizontal graph, so I have a horizontal best fit line, and it's a position versus clock reading or a position versus time graph, then the basic physics would be doesn't have any velocity. So if the slope of a position versus time graph is velocity, okay? Now I'm going to cite evidence. So I've given my basic physics. I just said the slope of the position time graph is velocity. Cite evidence. So now I'm going to say a horizontal line has 0 slope. So that's citing evidence, because now we have a 0 slope because I have a horizontal line. Now I can draw it together. And I'm going to say, since the position versus time graph, is a horizontal line, since the position versus time graph is a horizontal line, and that shows no velocity, then that would be true. So we've said there's no velocity because the x versus t graph is a horizontal line, and we know that the slope shows no velocity. So, and instead of that, I think we need to say, and therefore the slope shows no velocity at all. That's really what you would need to do to answer this if it was a free response. But it's not, it's just a multiple choice. So let's go ahead and take a look at the next one. All right, so now that we've got that, let's draw this. We're going to start at -4, and then we're going to go to -2 at this time. We're going to go to 0. Then we're going to go here. Then we're going to go to the next point, and then we're going to do one more. And then we're going to draw our best fit line. So I'm going to try to get this one a lot straighter. And I think I've succeeded on this one. Go ahead and pick again. This time you can just put the letter A, B, C, D, E, F, G, or if there's more than one, go ahead and pick it. So on your mark, get set, go. So A, B, C, D, E, F, or G. I'm going to give you about 10 seconds or so here. Does this one have no velocity, constant positive velocity, constant negative velocity? Does it have an increasing velocity or a decreasing velocity? Got one vote so far, which is awesome. And that vote is B. has a constant positive velocity. So on the AP test, that would be correct. It does have a constant velocity. It is moving up and to the right. You'll notice that my values are getting bigger in terms of the positive direction. Now, I do approach 0 here, but I'm not slowing down. I'm just moving from -4 to -2 in a second. And so -2 minus -4 would give me +2 divided by 2 seconds would give me 1 meter per second. So that is essentially my speed, and it is positive speed. So we say that I have a constant positive velocity. Excellent. Let's go ahead and check this next one. So we're going to do another one. Let's say that I have one that starts at 9, and then it goes here, and then we'll skip down to here, and then we'll skip down to here, and that's all they give me. And it does a straight line just like that. So go ahead and tell me which letter would you pick, A, B, C, D, E, F, or G, in terms of whether this one has a velocity or no velocity, and then is it constant or is it increasing, and then give me the direction. And I have one vote for C, and that would be correct. So anytime this is a straight line, my line is not as straight as probably what it should be. Woo, it's even worse that way. Then this is definitely a negative constant velocity. Excellent. All right, let's do another one. Let us switch, and you tell me what's happening here. So I'm going to just draw a curve. I'm going to draw a curve. So this is where we say there's a difference between plotting. So plot means you actually put dots, and sketch on an AP graph means you just draw a smooth line or a smooth curve. So curve or line without any dots. Okay, so you don't have to be very precise there. So let's say that I have right here, I have a curve and it starts to go like this. Okay, so now notice we are in the negative region, and I am starting at -8 and I am moving to 0. So does this one have a constant velocity, an increasing velocity, or decreasing velocity? Obviously it has to have some sort of velocity or it'd be a horizontal line. So you know you can't pick A. What would you like to pick? That is my question. And then we'll take a look at this one and we'll actually go through and really do a good job of analyzing it, try to figure out what's going on. So if you're out there and you can answer, go ahead and tell me which of these letters you would pick. And so now I see one person is picked and they have picked F. So let's check and see if they have picked correctly. And I don't have anybody else, so let's go ahead and check this one. So I think what I'm going to do is I'm going to change color here, because what we want to do is we're going to add to this. So let's actually change and let's make these blue. We're going to put on tangent lines. So remember, position versus time graphs to find speed, we want to find the slope. But this is a curve, and so you can't find the slope of this curve. However, what we can do is we can find the slope at different points. So right here at the bottom, it looks like that our slope has a value of something very close to 0. So here, our velocity is 0. At the midpoint, so right here, I'm going to draw another tangent line, and I see that this velocity is equal to, and I don't know, you could probably back this off and go from -8 up to -4. And we do that in 1, 2, 3 seconds. So that would be 2/3 or somewhere around 0.7 or so. So this velocity would be 0.7. And then we've got one more point that we can do up here, and we're going to go up this way. And notice that we have a huge rise over the run. And in 1 second, I have gone from -2 all the way up to 6. So I have a displacement here of actually +8, and I'm going to divide that by 1. So our velocity here is 8 meters per second. This one is 0.7 meters per second, and this one is 0 meters per second. So let's check and see what we have in terms of answers. It's definitely not constant velocity, and our numbers are going from small to big, so it's got to be increasing. So let's see if it's increasing velocity in the positive direction. Okay, well, that looks good. So it is increasing velocity in the positive direction. So our best answer probably is this one. Now, we did have somebody that answered decreasing velocity in the positive direction. So what is velocity? Velocity is the rise over run, and it's got to have some sort of, it's got to have a plus or a minus on it. And these are all positive, except for our zero. And so it is increasing in the positive. Does that also mean that it is decreasing in the, here we've got decreasing velocity in positive? No. Is it decreasing velocity in the negative direction? I don't think so either. I think our best answer here is going to be letter D. So it is increasing in the positive direction. Alrighty, let's move on to the next one. And this one is going to look a lot like this. So we're going to start here, and then we're going to make this one go this way, and we'll actually have it go, I don't know, about right there. We're going to do the same thing again. We want to know, is this constant velocity, is it increasing velocity, or is it decreasing velocity? So I will let you take some time here, and you can kind of see which answer would be the best answer for this one. And let's see if you can figure this one out. While you do that, I'm going to change. All right, cool. So I see somebody has answered for us letter E, and somebody else has answered letter F. So let's actually take and now they've changed their mind and they said, oops, and that's the way to do it. Make a mistake, just make sure you fix it. So that's perfect. All right, so I've got 2 votes for E. So thank you, Graham and Catherine. Let's check this. We're going to go straight across here. This is obviously a 0 meter per second velocity. So let's go somewhere in the middle. And right here in the middle, we see that we're going, we've probably got a line that looks a lot like this. And so we've got 7, and it's going down to about 0, and that's taking 2 seconds. And so we've got a change of -7 over 2. So that would be about -3.5 meters per second. And then if I do a tangent line right here, I'm going to go probably somewhere like this. And this is going to be a lot bigger than 3.5. So let's just say that this one is going from 1 all the way down to, you know what, let's just do it right here since we've got that. So we're going to go from 2, and we're going to go down to about -5. So 2 to -5 is going to be -7. And that's over 1 second because we only have about 1 second change there. So this is -7 meters per second. So you folks are right. We are increasing velocity in the negative direction. Excellent. Now let's do another one. So we've already looked at several. Let's kind of go back and review what we've done. We had one that was a positive velocity, okay, and it was constant. We had one that's a negative constant velocity. This one we said was an increasing velocity in the positive direction. Remember, you've got to draw all of those tangent lines all the way through. This one is increasing velocity in the negative direction. Okay, so let's try another one. Oh, the other thing that I'm going to show you is this. We have an acceleration here, and whenever I want to know what the acceleration is, I just draw a smiley face. And that smiley face tells you whether your acceleration is positive or negative. So my acceleration here is actually positive, and you'll see that because I am increasing speed in the positive direction. If I switch to the next one, I'm going to always draw your eyes above, never draw them underneath. So these eyeballs will show us that we are sad. And when it's sad, it means that your acceleration is negative. If I am increasing velocity in the negative, that means I have a negative acceleration. So that one is correct. So very good. So we've had 1 smile and we've had 1 frown. So our smile last time kind of went like this. Let's change that smile. Let's make that smile kind of look like this. So this smile is going to be more like this, okay? So here are our eyeballs again and our nose. If that's correct, tell me about acceleration first. Does this have a positive acceleration or a negative acceleration? And I'll give Graham and Catherine, since you guys have been so good at answering, go ahead and answer for me. Just tell me, is it positive or negative? You can put a plus or a minus. Notice it's smiling. Remember what we said, position versus clock. And yeah, Catherine, you're correct. It is a positive acceleration. Now, I know that Graham has jumped ahead. He said that this is a decreasing velocity in the positive direction. So let's go ahead and check. We're going to put a tangent line here. Notice that this is really big. And then our tangent line here is got a smaller slope. And then we actually don't really have much slope at all down here on the bottom. So this is negative really big. So I'm going to go ahead and put like 10. Here we can say it's about -5. And then this one is 0. So did my velocity, so these are all velocities, did my velocity increase or decrease? So you'll notice that my velocity is going from a big negative number to a small negative number. So it is decreasing in the negative direction. So it is decreasing, it's getting smaller in the negative direction. My velocity is decreasing in the negative direction. So actually, we have g. Does that also mean that we are increasing velocity in the positive direction? So could that also be an answer? So is this number, are our numbers becoming more and more positive? Well, I think for what we're doing, we really want to say it's decreasing velocity in the negative, because if we kept going and that curve kind of went this way, then we would be increasing velocity in the positive. So I think what we want to do is ignore what's going on over here and really look at this. We're going from -10 to -5 to 0. So our velocity is going from a big negative to a smaller negative to 0. So I am decreasing my velocity in the negative direction. So that one's a tough one to do. Let's do one more tough one, and then we'll take any questions that you have. So we've done one where we had a sad face this way, we've had a happy face this way, we've had a happy face this way. So let's go back and just make sure we don't repeat one we've already done. So there's a sad face in that direction. So let's do a sad face in the other direction. So this sad face, we'll just start down here. And notice it really doesn't matter where we start and stop, because these are positions, and positions don't really mean as much as what our velocity versus time graph would look like. So I have, oops, here we go. I have a big velocity here, so we're going to call it like +10, just because we don't have time to find out what it actually is. Here, maybe we have +5, and then right up here at the top, this would be 0 meters per second. And so this one, Catherine, you are 100% correct. This one has a increase in, so it is, I'm sorry, Catherine, look at this one again. I think your increase was for the last one, so that's really good. What's happening to our velocity here? Is it getting bigger or is it getting smaller in the positive direction? So is it increasing or decreasing velocity in the positive direction? Catherine, beautiful. Nice job. Good job, Graham. Right? So it is decreasing velocity, and that is in the positive direction. So we are decreasing velocity in the positive direction. So we just always want to be really careful when you go through and do these, because they can be very difficult. So use the tips and tricks that we've used. I think that's helpful. Tell me about the acceleration for this one. Is the acceleration positive or negative? Is the acceleration positive or negative? Yeah, Catherine, that's right. I'm going to give you one more kind of tidbit. Watch this. Notice that our velocity here is positive, but our acceleration is negative. If that's true, our speed should always be decreasing. If the two signs are opposite, then we have a decreasing, then we are obviously slowing down. Okay, so we have a decreasing velocity. Remember when we had ones that were getting bigger, okay? So this one, for example, whoops, this one was getting bigger. Our velocity, we'll see, was negative. So our velocity, we had a negative velocity and a negative acceleration. If those two signs are the same, we get something that's increasing or speeding up. Same thing for the one before that. Notice that our velocity was positive our face here is smiling, so our acceleration is positive. So that is also increasing velocity. All right, cool. So I am all yours. We have about 3 or 4 minutes here, maybe even 5 if we need it, or we can be done. Totally up to you guys. What questions do you have about any of these? Those are really all of the really kind of cool graphs that you can take a look at and really get to know and analyze. I think, we've really kind of covered all of them. We've also talked a lot about the actual AP test itself. We gave you some tips and tricks to make sure that you're getting all of the points. Even if you kind of flip things and you didn't mean to, you can go through and really find out what the velocity is. We talked about different types of graphs and what some of the names are, and really more importantly, what some of the equations are, so that if you need to make them straight lines like linearize, you should be able to do that. But I think that's about it. So if you have a question, I'll be around for another minute or two here to just kind of let you think. If you don't have any questions, that's absolutely fine too. Totally up to you. But I'll leave it up to you to ask a question if you want to. All right, I don't see anybody with any questions. So I think at this point, we're going to call this one done. There's not a lot here that you'll see. You really just have to remember some of the basics for this, but it's really, really, really tough. You know what? There's a question here. Very good. Awesome. So it says if slope and acceleration are opposite, it's slowing down. But if they have the same sign, is it speeding up? You are correct. Okay. So that would be 100% correct. I see that now. So you are 100% correct. If the slope, okay, is increasing, so let's go to 1. So here's 1. If the slope, let's move on over here. We're getting there. There we go. So here our slope is increasing, okay, and our acceleration is also increasing. It's speeding up. If we go to this one, same thing. It's increasing in the negative. So this one's increasing in the negative, and its acceleration is negative. That one's speeding up. So for the next one, this one, we'll see that the slope is getting smaller. So slope is decreasing, but it's smiling, which means that our acceleration is positive. So that one is actually slowing down. So that's a good one. And I think this last one, same thing. Our velocity is always positive. It is getting smaller, so it's decreasing, but it's positive the whole time. So our acceleration is negative. So that's kind of what you have to look at. So just be really careful. You want to see which direction the velocity is in and compare that to the acceleration. And the acceleration is indicated by whether it's a smiling or a frowning face. Anybody else have any questions? It was a great question, Graham. Excellent. All right, cool. So we will call this one done. This has been the different position versus time graphs. Don't forget, there are some more sessions later this week by a couple different people. One of them a student, another one a teacher. And I think that's it. So thank you very much for coming. Don't forget to spread the word that we're out here, Fiveable, and we'll talk to you later. Thanks, guys.